Here is the project cloud-based PE malware detection API. Here we have three tasks. Task one is about building and training the model. In this, we have the data set which we took for the project. And In this, we are using the AWS SageMaker for the deployment process, and the second task is about the deploying your model as a cloud API. In this, the second task will be using the SageMaker API to deploy our model on the cloud and create the API so that other applications can make use of this model. And the task three is about creating a client, like it's about the creating a web application using the Streamlit. I have used Streamlit to create the client. So when it's coming to the code, this is the GitHub account of the project. Here we have the important files about the project. So here is a report of the project, like a basic introduction. What are the project requirements? What is the data set we have used? Technical approach of what we did. The first is about data processing, data loading, data transformation, model architecture, model structure. All those information is included in the report project. Task number two, training framework, training process, evaluation matrix, deployment solution, web application. So this will be the API. So when coming to the code, so when coming to the code in this, basically for this project, we have used the libraries. We have used the following libraries like JSON, OS, torch.nn, torch.optim. We have used those. We have we have used that. These are the libraries which we have used. These libraries are in generally used for data handling, like JSON, NumPy, and Pandas are used for the data handling. PyTorch is for the deep learning, and Scikit-learn is for the evaluation. When coming down, the data loader class is for the data loading class. The main purpose of this is to load and pre-process the dataset from the JSON files. So when coming down, the train features, so the train features and the test features.jsonl are basically used for identifying the training files. So we prepared the feature X and the label Y's. Next is about the loading the training data set. Here we have used this for the loading the training data set. This reads the JSON files line by line. It also extracts the histogram feature vectors as the xtrain list, and the extracts the binary labels as 0 or 1 as the ytrain labels. When coming down again, this part. So this part is about for the it is similar to the load train data set, but this is for testing the data set and this is for loading the data set. Again, coming down, this code is for converting list to the PyTorch tensors. So basically, this converts the NumPy arrays to the PyTorch tensors for the training. Next, we are creating the PyTorch data loaders. This means we need to wrap the tensor datasets into data loaders for batch processing. Next, coming down, we are using the neural network model. This is the architecture. It has two fully covered layers. We have the input of 512 neurons and 512 neurons to 56 neurons, and the two neurons which are binary classification. Then batch normalization is there for the speed upping of the training. Then the dropout is it prevents the overfitting. Then we are doing the forward pass here. This forward part uses the ReLU activation, and it is again for the dropout to preventing the overfitting. Then as we are coming down, this class is for the training the model training. Again, this is the training loop. It loops through the epochs and the batches. It computes the loss and the back propagation of the update weights. Next, the this part is the evaluation part. It predicts labels for the test set and the calculates the accuracy. Then this is about the model saving. Then coming down, it's for the prediction. This class is for the prediction. It loads the saved model for the interface. Next, making prediction. This class is for the making prediction. It interfaces the it runs interference on input tensors. Next, coming down, this is for the running the uh, like it is for the running the data set. So it loads the data set, it trains the model, and makes the prediction. So, coming to the summary, this code loads the histogram based malware data and trains the neural network, evaluate it, and makes prediction. The final accuracy is 63.34%, meaning improvement could be made. For example, hyperparameter tuning, feature engineering, these all process can be trained. So, coming to the API, so here we gave I have kept the AI met as a folder, and I have given the streamlit run deployment.py as the command, and it gives to the API interface. We can see the input size of 256 on the left side, and I have kept the API as the enhanced malware classification detection. So I have given the input method as file upload, and I have uploaded the data of JSON-L, like here it is. I have uploaded. So here it is so here the file is processing. So here are the predictions. So there are 21,311 samples are there. So these are the predictions. This is the statistics of malicious count is 15,700 and benign count is 5,611. Accuracy is 49.65. The true positives, true negatives, false positive, false negative. This is a model performance, and this is a visualization of prediction distribution and the confidence distribution. So this is the brief info about the API. This application uses the neural network model trained to classify the samples as zeros and ones based on the histogram features. The model architecture consists of multiple fully connected layers with batch normalization and the dropout for regularization. Multiple input methods are supported to accommodate different data formats and use cases. So this